You guys are going to do a lab today where you're actually measuring the momentum of a couple of carts, and you can change the mass in the carts and you can change the speed of the carts, but you're going to be measuring or calculating momentum. Okay, and to do that you need to know the velocity of the carts and you need to know where the carts are at. And since there's two carts and they're moving in two different directions, we need motion detectors on both sides to detect them. Okay, so the setup today is like this. You have a motion detector on one end looking to the right and a motion detector on the other end looking to the left. Now, the issue with that is this motion detector over here thinks that to the right is positive, and this motion detector over here thinks to the left is positive, and this motion detector thinks this is 0, and this motion detector thinks this is 0. So what we're going to do first is we're going to go ahead and we're going to tell our lab quest that no, we actually need to re-zero our sensors. We need to retell them which direction is which. So the first thing you do, you plug in your two motion detectors into your lab quest, and hopefully you come up with a screen that looks like this. You have two bars, both measuring position. Okay, if you don't get that, then you can just push File New, and it'll get rid of any old data and pop up with this new data. Okay, the duration of 5 seconds, that's plenty long. Okay, what you need to do, and it doesn't matter which one, okay, for both of these sensors you're going to click on them and choose 0. Click on them, choose 0. Okay, and so what we've just done is we've effectively told the lab quest that 0 is actually right at the edge of each one of these carts. Okay, the other thing we need to do is we need to reverse one of the sensors. Okay, and by reversing it, if you just touch it and choose reverse, that means that now they both think that to the right is positive and they both think that to the left is negative, so that when the carts actually start to move this direction, this sensor right here will read that as a positive change, okay, because this is 0 right here, and we reversed its direction, so this way is positive. This one will also read that as a positive change because it's 0 and this way is still positive for it. So what we've done is we've established our reference frame and we've assigned a positive direction. Alright, so then we need to go ahead and collect data. And the carts can actually be used in a couple of different ways. Okay, one way they stick together. So in the picture I have them stuck together, but if you reverse it, so the plunger cart, the plunger is towards the middle, then they're actually magnetic and they'll repel each other because the magnets are polarized that way. So you have north to north and south to south. Okay, so I'm going to go ahead and collect some data real quick, and then we're going to take a look at what that looks like. So we're going to go ahead and push one cart into the other. Now I'm going to start with the cart in the middle at rest. I'm going to start with the cart on one end and I'm going to give it a slight shove, a gentle push into the other cart. We don't want them to actually smash into each other. We want the collision to be gentle. So I push the one, it pushes the other, and data collection stops and we're good to go. And these are the two graphs that popped up when I did that. Okay, now I'm looking at a lot of stuff. I don't want to look at all that. So I come over here and I look at the left side and I'm going, all I want to see is velocity for the first one. So I see D1 velocity. I want to see D2 velocity over here. That's telling me motion detector 1, motion detector 2. Okay, now there's a lot of information in this graph and we need to go ahead and analyze it. Now, when I pushed the carts together, what I did is I had one cart at rest and I had one cart that I pushed. Okay, now let's go ahead and look at each part of this graph. Okay, this part right here, okay, this cart's not moving and neither is this cart. They both have 0 initial velocity. Okay, then I gave the one cart a push, and so right here this cart is starting to move, and right here I let go of it, and so it immediately starts to slow down a little bit in this interval because of friction. Okay, but it's mostly moving with a fairly constant velocity. Okay, now this is my before time, and I know this is my before. This is before the collision, and this is when I want to start recording velocity, because right here, okay, in this time interval from here to here, both of these carts undergo acceleration. Okay, this one's velocity changes dramatically, and this one's velocity changes dramatically. So I know this is when the carts started to move. This is when the carts collided. Right? Push this cart, carts collided after the collision. Alright, so on your lab there's a couple of things for you to record. It asks you to record your initial velocity of the carts, and it asks you to record the final velocity of the carts. So what I need you to do is find where your collision is, and this is my collision because both carts undergo pretty good acceleration. Okay, this is right before, and we want to use velocity right before, right, because friction slowed it down. Right before the collision, and this is, I'm going to click this one position left. Okay, I see that this cart was initially at rest. It has 0.001 meters per second velocity, essentially zero velocity. And my first cart, the cart I pushed, was moving at 0.42 meters per second. Okay. Then they collided, and that's what this graph shows right here. This thing right here. This cart goes from zero velocity to non-zero velocity. This cart goes from non-zero velocity to almost zero velocity. So I come right after the collision and I touch there, and I can see that the velocity immediately after the collision, and that's the velocity I want to use. Okay, and I can't. Okay, there we go. The first cart's now moving at negative 0.005 meters per second, and the second cart is moving at 0.387 meters per second. So in my data table I can record that, and it's important, right? We set this up so that negative matters, so you do have to record a negative velocity. Right, and you're going to do that for a variety of different runs. So you can do a couple of them the same if you want to try this one again. Make sure your data is good. Then you can add a bar mass to one. You can add a bar mass to both. You can have them move towards each other. You can have one stationary. But you're going to do 6 different runs where you're looking for velocity from each cart right before they collide, velocity of each cart right after they collide, and you're going to record that information.